Thanks, Kaspar. Great to see you. Hey, folks, I'm Andrew Davidson, SVP of Products here at MongoDB. I'm coming at you live from New York City. Our headquarters is not too far from Times Square, for those who are familiar with the city. I love the platform engineering community in general, and I'm really happy to be here.
Great. And I'm Kaspar. I am the CEO of Humanitec. We are a platform orchestrator. But I'm here more in my capacity as a platform engineering groupie, if you want. And I am coming, I'm currently calling in from Tunisia, where it's 37 degrees, so very hot. But this conference has climate, so this is very helpful. Andrew and I had a chat, I don't know, Andrew, like 6 months ago, something.
Something like that.
That was like integration related, but we really we found that mutual love for platforms, for the platform engineering space, and actually for the question around abstractions, which I think for me is a very, I think it's a two-edged sword, if you want. On the one hand, right, you want to have abstractions because abstraction means simplification. And then on the other hand, you don't want to have abstractions actually, because you don't want to restrict developers. You don't want to take away context and all of these elements. And I think what we want to do today is talk about exactly that. And we want to present a model, a new model called the declarative application model, and in general, dynamic configuration management, to actually propose a new path on how to, and a new model on how to think about this. So our title today is Composable Abstractions and Why You Should Care. Andrew, if you think about abstractions, what does that mean to you?
Great question. You know, to me, over the decades with computing, I think we've all seen a move towards higher levels of abstraction, of course, over time. We as software developers, software engineers, platform engineers, SREs, et cetera. In general, our whole approach is to be able to move everything towards slightly easier to use systems at operating at higher levels of abstraction so that we can end up doing more with less. Now, a big part of that is so that we can get the benefit of doing more and more in code, of course. It's not about going to the, kind of human level of I can just do everything in a GUI, but rather about getting to that sweet spot where I can manage everything in a declarative model in code so I can get change management and all the benefits of code control. Now, the challenge traditionally has been, how do you bring that kind of an approach to all of the layers of the stack? And there's kind of lots of ways of coming at this problem, obviously, with the infrastructure as code players, thinking about it through the infrastructure lens, us with MongoDB Atlas, or we conceptualize ourselves as a developer data platform, kind of thinking about it at the stateful tier. But I think ultimately there's been something kind of lacking that really satisfies the needs of an application developer to conceptualize all of those layers in a cohesive way that allows them to move fast without feeling like they're operating so low in the stack that they're doing all the plumbing, but without operating so high in the stack that they lose control. And I think as platform engineers, you're always thinking about, how do I want to be able to move fast. I want to have the ability to not care about the details as much. But I also, as operators, you can't give up control. At least you don't want to give up control on the things that you know are vital to the health and the service levels you're providing. So finding that sweet spot, the right composable abstractions to build with, is the need of the times. And if you look at what the hyperscalers have done over the last 15 some odd years, is to introduce dozens and dozens of very specific services. And I would argue that they're just a little bit raw in isolation right now. And what we really need is to be able to operate with something that allows you to compose one level up from them. That's the need of the time. And I think that's what you've been working on, Kaspar.
To a certain degree, absolutely. And like I'm working on, for me, means more like what's a model that we can apply. And I think that's something that the platform engineering community is so interested in. Like what's the mental model we can apply, right? If we think about abstraction in general. So it's really less about product, or do we do this, or like how, if in a way you have on the one hand the option, we're leaving people two options at the moment, right? You want to you want to say, hey, you go the ultra complex, everybody does everything, everything is all over the place. I have to make sense myself. Here, just basically you build it, you run it in the worst sense of the word, really. And then on the other hand, I can do like Heroku or some of those newer PaaS players. But for us, basically, platform engineers who are concerned with larger scale systems, the enterprise, and all of its beauty, right? How can we actually think about abstraction? So exactly. So the first thing we want to speak about really is that like how to think about abstractions, and then how to do that the right way, and then actually about a layered model that you and I have been going back and forth on. I want to start with by again looking at the trade-off that we're doing here. From your database perspective, and I mean SVP product at MongoDB, you're thinking about, you know, database, what's the layer of abstraction? How can we make that simpler? You've been hinting at that super interesting question that we're all, you know, looking at. If you're looking at an Amazon AWS console, there is this huge amount of complexity and things you can tweak. And why? Because, I mean, obviously, if people come to you as an infrastructure player, they want to have the ability to actually tweak every last little screw. At MongoDB, how do you think about and the data platform you're building? How do you think about the trade-off between the need for low cognitive load for the developer, but full-on tweakability, if you want, for the infra people?
It's a great question. I mean, it is interesting that you mentioned AWS, which of course is a wonderful partner of ours. But
yeah,
you know, I think it would be fair to say that when you sort of log into that AWS console, it's both incredibly empowering, but also incredibly overbearing. You realize, as a platform engineer, I have to build an entire scaffolding to make sense of doing this at scale across my dozens of application development teams, to use it cohesively and to use it in a safe and controlled manner. And so for you as a platform engineer, there's that tension of how do I deliver the self-service agility that I want those application builder teams to have, with the centralization of controls and best practices that you as an operator, you know, hat wearer, have to think about. And so finding that sweet spot has been kind of a key North Star for us as we conceptualize how to do that for state. And what we realized when we kind of reviewed the marketplace of how people had started adopting data and state, in particular in the public cloud, we saw an interesting trend. Folks over the decades had, of course, you know, gone big in relational databases. Those came out in the 1970s, and a huge amount of inertia exists around these legacy relational databases. But what we saw happen was, with the rise of cloud, the rise of mobile, the rise of mass proliferation of online digital access, the scalability requirements started going well beyond what relational databases were built for. And so you saw this kind of proliferation of what I'll call more niche point database solutions. You saw the rise of key value stores for high availability and scalability. You saw the rise of a variety of other kind of bolt-on solutions, search engines that specialize in synchronizing data to make data searchable. And what you sort of typically saw was that applications would end up sprawling across a bunch of different stateful engines. You might have a relational database powering the kind of center or the core, key value powering certain parts that required more scale. Then you would have the search engine bolted on, and then you would wrap it all together in a caching layer to make it fast. And we realized this, frankly, presented a market opportunity from our perspective, because we saw that essentially this concept that required the builder to, you know, first of all, become expert at operating multiple different data engines, an operational transactional relational database, an operational transactional key value database, a search engine, a caching engine, and potentially an analytics store. Instead, what if there was a world in which they only had to become experts at operating a single endpoint? And what if we could make that single endpoint capable of expressing the wide variety of use cases that traditionally might have sprawled across those many services? So over the years, we thought about how do we make it so that all of the things that people traditionally would use a legacy relational database for let's build that functionality into our database. So we would introduce multi-document ACID transactions, for example. And the scalability and the high availability that you get from a more niche key value store, we realized we can build that in with our distributed capabilities. In fact, we've always had that from day one. And you realize key value, you could argue, is really just MongoDB style documents, but with a single index. And so you realize that document with secondary indexes is just a superset of key value. And then we've realized we can lean in and actually introduce the full power of search, fully managed and accessible through the same query interface. What this means is you can have a singular endpoint in the cloud that gives you an abstraction that basically solves for you the traditional operational scalability, high availability, search, and analytics capabilities that you need for modern applications in one service. And as a result, you don't have to become an operational expert on multiple engines, nor do your developers have to sprawl across multiple endpoints, nor are you securing multiple endpoints. It can all be in one. And so I think this idea of an elegant integrated abstraction that we conceptualize again as this developer data platform that can service all of the needs of your application is totally in response, essentially, to that idea that the hyperscalers would tell you, no, it's a good thing to have N different systems powering your application, because they like that model. They don't want to have to, basically see you consolidate on a cohesive, elegant, integrated model. They'd rather have a bunch of specific lower level primitives. But we would say, we've seen that our customers have proven that they want something more integrated. The velocity and standardization that comes about from that is so synergistic with, I think, the core ethos of platform engineering.
Right, and one of the reasons that I really wanted to have that conversation with you is because we're always, trying to bring home that point with the customers we work with and the many teams that I speak to, where I'm always I'm basically trying to drive two things, right? If I'm looking at setups, like how can we decrease cognitive load for the developer? Because cognitive load, like if you decrease cognitive load, you increase speed, right? You increase everything, convenience, speed, happiness. And second, and that's a really important point that you made there, is standardization. And what I like to look at these days is standardization by design, right? How can you design systems that by using the systems, following the systematic approach, actually drive standardization by design across the enterprise, really. Now, you've hinted at this before, the common interaction methods, the rise of infrastructure as code, the idea of declaratively describing something in code, which I think is something we don't want to get away from, right? It's something that I personally deeply believe in. I'm very reserved on the idea of like those typical ClickOps style approaches. And if you look at at the same time, we see this whole space, platform engineering, internal developer platforms, really is just kicking off. Gartner 2 weeks ago put it on the hype cycle, is using the term more and more. But at the same time, there is a lot of vagueness in the design of these platforms. As shots in terms of product, you envision the interaction method of the future of the platform, the operations, platform engineering persona, the developer with Mongo. What's your vision and feeling there before we go into that layout model?
Yeah, great question. So it is there's so many different sort of classes of customer that I always think about. So to kind of give you a perspective of the full spectrum that I'm always thinking about, we have just this incredible number of people who are signing up for MongoDB Atlas every month, who are in many cases students and learners. The number is mind-boggling. 150,000 sign up every single month. And now, most of those are obviously not going to be a sophisticated, hardcore enterprise customer with a platform engineering team. Most of them are, solo developers building net new use cases, learners, et cetera. But of course, if you go up that spectrum, you start seeing larger and larger use cases, more and more sophisticated customers with more and more operational sophistication. larger and larger existing cloud estates, or essentially much more inertia or momentum towards building great things, whether it's well-funded startups or traditional enterprises, building those digital experiences that are so important to their businesses. So as you go up to the extreme end of the spectrum, you get this massive, it's very interesting how in the database industry, you see this orders of magnitude larger workloads. So some of our largest customers are powering workloads that are literally have millions of concurrent users. Largest games in the world, largest banks in the world, largest crypto exchanges in the world, et cetera. And so delivery platforms, you name it. And so when you think about that full spectrum, I like to think about how do you enable a builder to have an amazing experience from literally like I'm writing my first line of code, the kind of thing that 10 years ago a Heroku might have nailed. I want to make sure that there exists an ecosystem. We're not going to be the only player. We're the developer data platform. There's always going to be more. That we enable someone from that stage to grow up, and over time, as they find that product market fit and growth and scale, to grow up and become that massive scale customer with tens, literally millions of concurrent users. And the reality is, to make that possible, you need to sort of imagine the right abstractions for the right team sizes, team dynamics, and enterprise requirements at every level of that spectrum. And I think that's why open and composable is so important. You can't come in with a sort of, there's only one way to do it mindset. Because the reality is people have all kinds of different needs and requirements. And if you can find something that's flexible, but gives you the ability to kind of create the standardization that you and your team require, and you as a platform engineer are in a good position to kind of gauge the requirements of your team's needs, then you have something really interesting. As an anecdote, I remember somewhat early on in MongoDB Atlas, one of our larger gaming customers, these are massive game type customers, they experienced an outage in a non-production environment. And I remember, I thought to myself, actually I said to them, I had a conversation with them and I said, at least it wasn't a production outage. And I'll never forget what that individual said to me. They said, you don't understand. An outage of a non-production environment is an outage of our production app dev assembly line. In other words, we're operating at this scale where all of our software engineers at all times have to be continuously adding software value, moving things forward for our business. And if there's ever an outage in any of that, it's almost like Tesla having an assembly line outage. That's a tier 1 business problem. And so for me, that was a real light bulb moment that the standardization and building the app dev assembly line, not everyone's going to be there in terms of understanding that that's their need. Someone who's early in their journey, if they're the only developer on a project, they're building the assembly line for themselves. They can fix an issue quickly, et cetera. It's very different than once they're at massive scale and dozens of engineers potentially are twiddling their thumb until something's fixed. And so I think enabling people to grow into that assembly line and to have the right services that can be composed and combined to make that possible and easy without being too opinionated, remaining open and composable is really exciting.
Yeah, incredible. You said a lot of good things there. First of all, the interesting thing in the digital world, right, is that on the one hand, we are a gigantic factory, right? We ship a huge, like as an industry, we create a lot of value and huge amounts of revenue flows through our system, and the developer like you do not want to have an interruption in the developer assembly line. On the other hand, where like a Tesla is always manufactured the exact same way, right? You have more variance in the assembly line. So you brought home another point, and that means you want to have that dev assembly line, but it's basically opaque, it as in the digital world. And that's why it's so important how we speak about abstractions. Those have to be opaque abstractions, meaning that at any point in time, the developer can actually deviate from that standard assembly line. Netflix calls it the golden path. And there are several other ways people use that. You want to be able to actually go under the hood, circumvent the assembly line, and be able to customize the specific part of that application to your specific needs. So the output of the application developers is less standardized than the output of any other industry, which frankly makes it so tough to build these assembly lines the right way. And that's why it's always about, I love that term, opaque abstractions, right? Give them best practices, give them golden paths they can follow, give them paved roads, that's the Netflix term, paved roads, but make sure that at any point in time, they can actually deviate. They know exactly the implications of what they're doing. They're not losing context, and so on and so forth. Did I get that correctly? Is that a right way of putting it?
I think that's a great way of putting it. And I think the key thing that can easily be lost, because we can all kind of sit here and go, oh yeah, this all sounds great. Let's do it all. We sort of, going back to your point before of cognitive load, it's kind of like being a pilot of an airplane, right? There's only so much you can conceivably be on top of before you need to have that co-pilot. Now, when it comes to the nature of these customizations, I love that visual of kind of like all these, distinct assembly lines that are, bespoke to the needs of a particular digital use case. There's a question of, it's only possible to achieve that if you're not mucking around in the lower level plumbing. This is something that I think really needs to be we need to remind a lot of people. A lot of folks get somewhat threatened. I've seen this because I've seen us move, countless customers from a traditional on-prem mindset into a public cloud mindset, and then to move up levels of abstraction into more of a software as a service or platform as a service model. Some people can actually almost be threatened by giving up some level of visibility or control of some of those lower levels in the stack. Now, I would remind everyone, the reason you should want to lean into going up a level of abstraction is that it allows you to now do a lot more, inclusive of being capable of dealing with all of this heterogeneity at that layer that's going to unlock a lot of business value for you. In other words, by not doing this lower level stuff, operating system patching, abstract that away. You're going up a level. Network configuration management, abstract that away. You're going up a level. The more you can do that, allows you to do all of this, the bespoke stuff that's so valuable to all of those builder teams, rather than them feeling like they're being required to follow some central set of rules that don't apply to them. To be completely honest with you, this one's somewhat personal for me. In a world in which people choose their tools, you have to meet them where they are. The reason I say it's personal is MongoDB wouldn't exist if it wasn't for the phenomenon of shadow IT. Let's be honest. Nobody was told centrally, go use this new database. Developers just pulled it in because it was such a great abstraction for what they needed, the document model and all that stuff. And have done so ever since. And now it's kind of become more standardized into the fabric. That's why many of the platform engineering teams on here probably use Atlas today. But recognizing that shadow IT is a real phenomenon, as platform engineers, our goal is to meet those builders where they are with their needs addressed, never to sort of say it's this way or the highway, because they're going to go work around us. And that's basically exactly what we're trying to avoid, because that kills the standardization and all the controls that we're bringing to bear.
Perfect. You couldn't have said better. Absolutely. So, and I think one of the things that we actually want to look at here is, let me actually take that here, is the layered model. A layered model to structuring a layered model basically to describing an application that allows for just that. And that is part of a larger movement that we're observing. We call dynamic configuration management. And that is the art, if you want, to describe an application in its entirety in a layered model, right? And then where the lower you go in the layer, the less abstraction you have, basically. And you let the individual user the choice where they want to stop in terms of cognitive load, really. Like the lower you get in the model, the higher the cognitive load, the higher the granularity of what you can actually change and achieve. And the result is actually exactly what you said, standardization by design, and all of those different components. And that's actually what I want to, or what we want to actually touch on here right now, and dissect that in a little bit more detail. This is a very new field, but we're seeing that has an incredible pull inside the enterprise. I want to take a second and actually explain what that model means. First of all, the different elements of the model are more or less the application itself, and like the application code, the application configurations, and the infrastructure configurations, plus a recipe, a lookup function, what infrastructure, what config defaults to use in what situation. You know, if you want to really simplify it, that's what it comes down to. So the code of workload, the application configurations, the infrastructure configurations, and when to use what. Now, if you wouldn't use that, how would you do it? And the pretty basic answer is you would have your application configs, and then you would have, you know, some app configs in YAML files, some infrastructure as code. You know, pick your favorite tool that's hot at the moment, Terraform, Pulumi, Crossplane, CDK. You would actually express that as code on an end-by-end basis, and then you use to actually sync that in a GitOps fashion. Now, there's nothing wrong with, you know, the tools. Forget the tools. Has nothing to do with tools. The problem with actually stiffing everything into repositories on an environment-by-environment basis is that it means that our individual user cannot actually choose what level of abstraction that they actually want to follow. So they do not want, let's say they want to apply a change on, they want to add another workload to a distributed system, right? That means they now, and then the workload consumes MongoDB Atlas. Let's just take that example. So that means I need to do that environment to environment. I need to figure out how to deal with the app configs. I need to figure out how to express the database, and I need to express how to actually define the relationships between all of those, plus they change, right? You might have a Mongo instance for, or a database in an instance for dev, staging, prod, ephemeral environments, whatever. And that is actually creating just what we said, cognitive load, and then overhead for the teams. So that's sort of the problem statement that we see ourselves confronted with. Does that make sense? Perfect. So the result actually is, or the approach is that layered approach to say, hey, we actually say, we take what we have, right? Let's stay in the examples we use. Like we have a couple of Terraform files to express things, and then we have our configs expressed in charts, whatever, Helm charts, because we are deploying into a Kubernetes world. And the idea is to say, well, keep that as is, but pull apart the environment agnostic from the environment-specific elements of configuration. And that now means we actually have the workload code. That's the workload code. No changes there. You build that with a CI pipeline, push that to a registry, keep that as is. And that's what the individual contributor usually deals with. Let's imagine our, React.js developer building an enterprise-grade React app. That's the environment that they're still focusing on. Then we are adding a second layer, basically, that's an abstract workload configuration, an abstract description on how my workload relates to other workloads, as well as to dependent resources. Let me actually show you one. That is something that's currently being donated to CNCF, and we've been using it for a while now. Platform agnostic workload specification. If you actually go look at this one specification, it's actually describing one workload in relationship to other workloads and dependent resources. Hey, I'm a workload. My name is product catalog. Have a resource dependency on a database of type Postgres. I have a DNS, and then I have a parameterized connection string that tells my workload how to connect to my database in that case, right? So we're not saying what exact, stick with that example, MongoDB Atlas. We're not saying like what exact image. We're just describing in an agnostic way how these things relate to each other. Low cognitive load, super easy to digest, doesn't specify lots of things. And the developer experience in that example could be, hey, I'm doing pause compose to run this local, will be converted into Docker Compose. I'll run like pause context staging, will actually create staging manifests, will wire up to a atlas that's just for staging purposes, following your single API thing. And the question now is, how does that system know how to create the app configs, how to create or match the right the right database, DNS, file storage on a situational basis? And this is where actually the other layers of that layered approach come in. We have our workload profiles. You can think of them like empty Helm charts that weave in CPU minimum allocation and basically tell us how to create the manifest. And we have the infrastructure profiles. And this is exactly what you were referring to, where you can say, hey, what are the best practices that as a platform engineering team we can actually set? So we have the specific database that's running in an instance, one for dev, one for staging. We have a separate production one that's just dealing with production workloads. And those are registered, those are expressed as infrastructure as code, Terraform, Pulumi. It's basically a collection of all the resources that I could potentially connect to, and to actually create and scaffold new services to drive standardization by design. We give the recipes how to create new infrastructure if that request comes in. So that's the infrastructure layer. And last but not least is the lookup function. Hey, when should we use what profile? Hey, you should use the profile for that MongoDB, and you should actually match that to the request, to the abstract request. I need a database. If I am in the situation that I have a app ID of type whatever and an environment of type staging. And so that's actually the idea. 5 layers, right? Actually pretty straightforward. Now the individual contributor can actually define where do I want to stop in terms of cognitive load. Workload and abstract config can actually be with the individual contributors. And if I want to drive standardization by design, or if I want to, I have harder government requirements, more security, whatever, I can have the workload profile, infrastructure profile, and the matching criteria written by the platform team, or I can do that by seniority level, right? Advanced engineers can go off path and actually change the infrastructure profile right away. And that provides a great way of actually thinking about these things in an intuitive and, in an intuitive, low cognitive load way without ever abstracting, because I can, choose the layer that I can deal with. And you will need to build yourself or work with a platform orchestrator to actually compile that model into something that I can then, execute. But that is a phenomenal way of driving standardization and self-service in the enterprise that we're seeing being adopted now all over the place.
This makes perfect sense to me. I mean,
go ahead. Yeah.
In a way, it's like you're. It's funny you mentioned it. It's about bringing standardization, because what you're describing here is just bringing a standardized way for us to conceptualize what we're all sort of doing in our own ways in some form today, but without all of us having a shared way of, a shared nomenclature, a shared way of conceptualizing, a shared way of expressing essentially what we're all doing, which is this declarative application model, more or less. It's obviously way more ad hoc in most cases, and/or it's just in some internal wiki somewhere, and/or it's, teams just in a bespoke way collaborating. But if we can together operate at this level and define these key building blocks and not have to deal with some of the lower level primitives as plumbing, basically, as well as not having to deal with as much, everyone's kind of doing their own Wild West, figuring it all out from scratch and landing on something more or less like this, thinking I'm supposed to be using infrastructure as code and Helm charts. So I'm going to do it on my own. But having a scaffolding that kind of brings it together and makes it make sense, I love it. I mean, again, both of those two examples to me kind of sum it up. Infrastructure as code and Helm charts. Both of them are so powerful. Yet the second you look at what they do, you realize in isolation, they just can't, I need something that wraps it all up and brings it together. And frankly, the same goes for us with MongoDB Atlas, the developer data platform. We're ultimately in a battle for stateful workload mind share. We want to kind of win over more workloads, pushing their stateful needs to us, as opposed to sprawling across a bunch of other databases, niche services, legacy relational databases, et cetera. And I have to be honest that we don't live in isolation. I mean, we're database. We always need what you're referring to here as the workload tier to be relevant at all. A database without an application is frankly somewhat useless. And so we kind of always know. It's funny, right? It's funny that every one of my ridiculously large, I've got whatever it is, 35,000 paying customers. Every one of them has a whole application management framework that they no doubt have landed on for themselves. I kind of get to just know that they must be figuring something out, because otherwise they wouldn't be using us. But it's always been a little bit of a mystery. There is no standardization there. And so going up that level and offering it is just clearly the need of the time.
Absolutely. All right. So we started a little late. Very sorry again. But now so that means we're also late with questions. But I actually want to open the floor and give you the opportunity to ask a couple of questions. We actually have the first one for you here, Andrew, from Hussein. Thank you so much for the question. And if I actually two separate questions, and I'll try to summarize them. Hussein, correct me if I got that wrong. So what he's asking is, so he's thinking of a company with 150 teams. All of them are using MongoDB on the on-prem setup. Then they're deciding to move to Atlas. They're not actually adding enough abstractions. And from how I'm reading this, they're not actually strict enough in enforcing those abstractions. Things end up all over the place. They're incredibly hard to maintain. So how should you think about the, again, I think level of abstraction and how do you, and that's such an interesting question, how do you find the right level of abstraction for your specific team?
That's a great question, Hussein. Yeah, I mean, I don't know if it was a hypothetical or if it's actually your lived experience with these 150 applications moving from on-prem to Atlas, but we have many customers dealing with that type of challenge. And I think what happens is there's multiple ways to look at it. There's sort of the ideal, let's call it the ivory tower example, where you've set up the standardization before people have started adopting a platform like Atlas. And as a result, they kind of come in cleanly from day one with the sort of knobs that you want to make available in the kind of infrastructure as code and broader declarative application model that you're comfortable giving to your end users as parameters they can control. That ivory tower model oftentimes isn't the reality, because oftentimes those builders have moved on their own. I think we all know that there's kind of a platform engineering teams may not be kind of in the driver's seat necessarily. And so another reality that can come about is those teams come over to Atlas on their own to some extent. And I'll say for those folks, there's still kind of a wonderful upgrade that you experience from a traditional self-managed or on-prem or self-managed in the public cloud mindset moving into a developer data platform like Atlas. And that comes from, you now have the ability to, through a couple of API calls in a standardized, centralized way, understand what everyone's doing across the platform. And you know that Atlas isn't going to allow your people to, do the dumb stuff. It's never going to allow them to disable TLS encryption over the wire or disable database authentication. It's going to have the kind of fundamental nuts and bolts, great safe defaults, just non-negotiable, always there. So you'll know from day one that they're probably adopting with a decent posture. And then you'll be able to audit on top with those APIs. And if you want to start going in and layering in recommendations, you as a platform team, you could say, hey, this team, I noticed that, it appears your staging environments are oftentimes running when they're not being used. Why don't you scale those down or pause them when they're not in use, for example? Or another team you might be able to point out is, using a different version, let's say. You might recommend that they take advantage of some of the modern capabilities in the newer version, or any number of other possibilities. So again, instead of it being like hundreds of VMs that essentially are opaque to you as a central team, Atlas means you now can start kind of wading into, getting on top of what's going on there and adding value in whatever way, depending on where you are in the maturity, you can start by adding value in ways that is more kind of, hey, let me help you out with advice, see what you're all doing. And by the way, start asking ourselves, are there blueprints here that we together want to standardize on more, et cetera? Just makes it so much easier to do that.
Yeah, perfect, cool. Then we have a question from Janina on what are innovations on the Atlas front that will serve platform engineers in the coming years. So yeah, is there anything you can share from a product perspective, or things that you're interested in that you look at that you can share?
Great question, Janina. I don't know if you're an expert Atlas user today or not. So for those who may not be yet, I'll just provide some sort of high-level overview of some of the key building blocks to be aware of. So Atlas out of the box, first of all, provides a wonderful GUI for people to learn from, but the expectation is that everything in Atlas should be something that you can configure via the APIs, or administrative APIs, or infrastructure as code, Terraform, Pulumi, et cetera, or our Atlas CLI. And the way Atlas is organized is you can create multiple Atlas organizations, and you can link those up for shared billing if you so choose. And inside of each Atlas organization, you can have up to hundreds of Atlas projects, and each Atlas project can have up to a couple of dozen database deployments or database clusters inside of it. And typically the way these Atlas projects are used is maybe for a particular team, app dev team, they might have a production project, a stage or a test project, and a development project. So for simplicity, let's imagine that every app dev team you might create 3 projects for, and then you can easily have, let's say you have 100 teams, you can easily therefore have those 300 projects. You can configure them so that those teams can authorize into only their appropriate projects. Maybe the prod project is locked down, can only be managed in code, whereas maybe the development environment is more something they can interact with directly. It's very easy to kind of stamp out or configure in code this whole construct, which allows you to, again, create that stateful portion of that app dev assembly line. Now, your application, declarative application model that we're talking about here, we're just going to be a part of that. But because you can express essentially all of the major needs, the stateful needs, persistence needs of modern applications in this platform, you're not going to need to deal with all of those other systems that you might traditionally have felt you had to bolt on, allowing you to focus on your app tier and how you're going to manage it. Is it going to be, inside of Kubernetes, or is it going to be inside of a serverless paradigm like Lambda? You can think about all those different components, and I think it's a simpler set of building blocks. You'll see us over time just keep making all of this easier, making it, I mentioned before that monitoring in to understand what people are doing and kind of understanding existing configurations. You'll see us layer in on top of that, essentially more ways for you to more easily audit and control and report on deviations from what you think are that golden path. Again, without, it's always that fine line of reporting without reining in someone who might need something that's a little deviating for their own golden path. So finding that balance is how we're going to roll out more and more maturity around all of this in Atlas.
Sounds good. Cool. So I think we have to call it a day, although I would love to continue this conversation with you, and I'm sure we will, Andrew. This was a great discussion. Thank you so much. If you have other questions, feel free to ask in Slack. The platform engineering Slack is here for exactly that reason, and we'll get back to you there. Debate on YouTube and across all of the different channels. Andrew, thank you very much for spending this time with us today. And I'll hit you up when I'm in New York to have a good beer with you.
Look forward to meeting you in person, Kaspar. Thank you so much. And have a wonderful day, everybody, folks who dialed in from around the world, I'm sure. Great to connect.